All right, so today I'm going to be going over the last lesson, which is about recursion. Just like with the stuff we talked about classes, the important part is that you guys understand the more conceptual like stuff with recursion. Um, I would recommend you again to like try and practice this with Java. But it's most important that like the first thing for recursion is you understand how to read a recursive method. So like how to be able to look at a recursive method and be like, okay, this is what it actually does. And then the next part is being able to like design a recursive method on your own. So basically, what I'll go over is just like, what is recursion? Why do we use recursion? And then finally, how you should be thinking about recursion. So first off, recursion is kind of just like what I would call like a fancy for loop. It's basically a method that calls itself. And why I call it a fancy for loop is basically any for loop can be written into like, or any recursive method can be written into a very complicated for loop. So, and oftentimes like under the hood, compilers will actually turn recursive methods into a for loop. So, but in general, like a recursive method is just a method that calls itself. And this is sort of like a visual representation. So like we have a cat that's kind of like recursing into like the screen. So next, if recursion is just like a for loop underneath, why do we ever use recursion? So the reason recursion is good is in some cases, it's actually easier to think through a problem recursively. And also recursion makes things a lot readable if you understand like how to read a recursive method. Also, like there are some data structures, AKA like data trees, that are easier to implement using recursion. So basically it's easier, like this image here is basically a binary search tree. And a lot of the methods related to this kind of data structure is actually a lot easier to implement using recursive methods. And then finally, there are some languages that are a little bit based around recursion. So like there are some functional languages like OCaml or Racket or Lisp that have like this sort of other paradigm that's not really like Java, where like they really like recursive methods. So it's really helpful to be able to have like, to be able to think recursively, basically. All right, so finally, I'm just gonna talk about like how you should be thinking through a recursive method. So recursion is actually based on this basically this logic proof method called inductive reasoning. So basically it's sort of like a domino effect proof where it's like if you prove two kinds of cases, then basically it'll be true for the rest of the cases infinitely. So there are two parts of the inductive reasoning and recursion. The first one is basically your base case. So in terms of recursion, this is basically the condition where your recursive function actually returns a value. And then you also can think of it as like your base. I'll actually be live coding a recursive function later. So the next slide, I'll actually be just like working through an actual recursive method, like creating one. So maybe like once I actually start doing creating a recursive method, I think like some of this will sort of click, because like, yeah, this slide is a little bit of me like sort of talking at you about it. So maybe if you see it in code, it'll make sense. I could also also just implement this method and then show you like where like these boxes fit into like the actual code. Is that all right?
Well, yeah, maybe do the demo first. Maybe that'll clear it up.
Sure. All right, so this is the demo. I'm just gonna fork this. So over here, I'm just gonna be implementing two recursive methods. So both of these are more mathy. So one is factorial and one is Fibonacci. Is anyone not familiar with like the Fibonacci sequence or factorials?
I'm not.
Gotcha. All right. I can explain both of them to you then. So basically factorial is the, here we go. So basically factorial is like if you're given, say like a number x factorial, which is like this exclamation point, would be like x times x minus 1 times x minus 2 all the way down to times 1 basically. So once basically it'll take the product of like x all the way down to 1. So for example, like trying to think of an easy number. So for example, 3 factorial would be like 3 times 2 times 1. And then another rule is 0 factorial is 1. Does that make sense for factorials? Basically, like you're multiplying a number down all the way to like the value 1. And then if you do 0 factorial, that's also 1. Fibonacci sequence, this is a sequence that's like starts with 1, 1, 2, 3, 5, 8. And this is sort of like a sequence or a pattern where the nth term, so like say the third term, is basically the sum of the previous 2 terms. So like 2 is the sum of 1 and 1. 5 is the sum of 2 and 3, and then 8 is the sum of 3 and 5. So this is just like a number sequence that has a pattern to it. So these two are pretty good examples for or they're pretty common examples of recursive methods. So first, I'll just be showing you like how to create the or how to implement these methods recursively. And then once we run it, we should be able to print like these correct values. All right, so for factorial, basically we want 2 cases. So a base case, and then a recursive case, or I like to call this a recursive call. So basically, we want to first define like when factorial stops. So basically, factorial will stop when you reach 1, right? Or when or technically like you reach 0, because the 0th factorial is 1. So we'll basically define we'll check if I is equal to 1 or I is equal to 0. We'll just return 1, because that's like one factorial is 1, and so is 0 factorial. So that's basically when we're stopping this like factorial method. And then finally, all you have to do is a recursive call. So basically, we're gonna call factorial, and we're gonna decide like how we're gonna increment I. So for factorial, then we can trust that this method just works. Does that make sense?
I think so, but maybe when, I don't know how, is someone going to set a value for I at some point, or what? How does it work?
Basically, yeah. It'll like do all this stuff with the factorial method. and like do the recursive function. And then this factorial method will return an integer, and that's like what it prints out. So like technically it's the same idea as printing out just like any number like 3 or 10.
So factorial, that thing that you have highlighted is considered to be what, an integer or a double or does it have any I mean, can it's basically an integer, right?
Yeah. So in the factorial like
I see. Okay.
method header. Yeah.
Yeah, okay. Integer. Okay. Okay, thank you.
No problem. So yeah, so basically for factorial, it's like over here, it's technically like solving for this expression inside of like, or solving for this factorial method first before like doing the print. All right, so next we'll move on to something a little bit more complicated. So this is the Fibonacci method. The idea with Fibonacci again is just that like the nth term is basically the sum of the previous two terms. So if let's say n equals, and let's use array indexing. So this will be 0, 1, 2, 3, 4, 5. So if n equals 5, then basically n minus 1 is 5, or the n minus 1 term. And then the n minus 2 term is 3. And then the nth term, which is 8, is just the sum of the n minus 1 term and the n minus 2 term. So just like before, we're going to define a base case. And then we're going to define a recursive call. So for the base case, this one's pretty simple. So if like the nth term we're finding is either 0 or 1, we're just going to return 1. Because that's the start of the Fibonacci sequence. So this is basically when the recursive method stops. And then the trickier part is just defining this recursive call. So I don't think I've said this before, but recursive call, you're always supposed to return something. Otherwise, like it won't otherwise your method won't return the very end. So we're going to return some sort of recursive call that like calls the Fibonacci sequence. So up here, we're actually going to have 2 recursive calls in this statement. And we're going to add them together because these are going to be sort of like the n minus 1 term and n minus 2 term. So to find the n minus 1 term, we're just gonna call the Fibonacci method again. And then same with the n minus 2 term. And then that's it. That's basically like the Fibonacci method. So if we run it, it should return 3 and 0. Or not. Oh no, when I wrote the comments, no, I wrote the comments wrong.
Don't leave yet if you don't mind.
Sure.
Just a sec. Yeah, because I looked at this before class and I didn't understand it at all, and now I do, but that's because you've added so much. Okay, then could you move down to line number 15, have it start at 15 where or 16 will be done. Got it. Thank you so much.
No problem. All right, so next, oh shoot. So next, we could just go through the quiz questions. So first, what's a base case? I feel like I've already showed you the answers, but so is it like the case that leads to the method calling a different method the first time the code in the recursive method, the case that ends the recursion, or the case that leads to a method calling itself? So we have one answer for C, another answer for C. Anyone else have an answer? All right, so yeah, the correct answer is C. The base case will not always be like the first, or depending on like how you like to code your recursive methods, the base case might not always be like the first line. All right, yep, so the correct answer is B. So basically, the recursive case is basically when you don't reach the base case. So if you don't find a needle, basically when you find a piece of hay, that's when you basically want to loop back and continue your search. Any questions about that quiz question? All right, so question number 3, which of the following program structures is a recursive method the most similar to? So is a recursive method like a loop, an if-else statement, an abstract class, or an array? All right, so yeah, basically a recursive method, actually like what for a lot of compilers, they'll actually secretly turn recursive methods into for loops. But basically a recursive method is just like a really fancy for loop, but it's a lot more readable than having like a for loop that has a bunch of different conditions. And then finally, or second to last, we have this code, basically just this method called do something. It takes in an integer n, and it does some sort of like recursive call or something. So what will be the output of this code when inside the main method, I call do something and the n is equal to 3? Sure, like, yeah, it can be a little, like, especially when we just have a method called like do something, it's really like, it can be a little daunting to like try and figure it out. But try to go step by step. So like first, what's the base case of this method? When does this method stop, basically?
When n is greater than 0, does it stop? And no, it writes something out. No, it's if it's not greater than 0.
Yeah. So if it's
less than or equal to 0, then it stops.
Exactly. And it returns 0. So next, like in this recursive call, what do you think like this recursive call looks like? Like, what do you think it's trying? So we know like, first off, it's sort of like taking n and it's adding something. So it's adding the do something of n minus 1. So we sort of like think about it in like, let's say like, or if we sort of think about it on a greater scale, like do something, like, what do you think, just by looking at like this line, what does do something do? You could also try to compare it to some of the methods in the demo that we wrote. So like in Fibonacci sequence, it kind of like, we kind of also had something similar where it's like Fibonacci n minus 1 plus Fibonacci n minus 2. But in this case, we just do n plus do something n minus 1. So
I don't know.
Yeah, this can be like, this can be a little tricky if you're like not used to thinking recursively. Basically, we're sort of we're first off, we have this base case. So like we're sort of recursing down to n equals 0. So when n equals 0, we just return 0. And once we look at this recursive case, it's sort of like n plus the do something of n minus 1. So it's sort of like, if you sort of like think about it, it's like n plus n minus 1 plus n minus 2 plus like n minus 3, all the way down to like 0. So we're basically, this is basically like a summation. So if n was equal to, let's say 0, it will return 0. If n equals 1, then we return like 1 plus do something 1 minus 1, which would be 0. So 1 plus 0. And they would sort of like go on after that. So it's basically taking the summation of n. So once we get to 3, it would be like 3 plus do something 3 minus 1. Actually, let me see if I could, yeah, so like the correct answer, actually I'll put it in chat, it's C. So I can sort of, let me see if there's a way for me to write this out. So basically the general gist of this is, or this is.
We don't really know what do something means.
Again, like with what we talked about with Factorial and Fibonacci, the actual name of the method doesn't mean anything. Like this could be called like ABC, or even like even foo or something like that. But it's the content of the method that actually matters. Because like the in this like do something itself is not like a keyword or some sort of special name. It's just like a placeholder. Okay, so basically for do something, this is not Java code. This is all just nodes. The base case we identified as if n is equal to 0, or actually less than or equal to 0, we return 0. And then otherwise, the recursive case or recursive call, we will just do n plus do something n minus 1. So the example I gave for do something 1 is first off, we check that if n equals or is less than or equal to 0. 1 is not less than or equal to 0, so we'll go straight to the recursive call. So the recursive call would just be 1 plus do something 1 minus 1. So over here, we're just plugging in the numbers for like the general recursive call.
Yeah.
So what we do now.
What does do something for 1 minus 1 mean? What is it equal to?
So that's where we're going to figure out next. So next we're gonna solve for this like do something 1 minus 1 call. So this is basically equal to do something 0, right? Because we can just like instead of 1, yeah. So we just solve for that inside of the method or inside of the parameter. And next we'll check, is 0 less than or equal to 0? That's true. So we've hit the base case. So return 0. Now, once we get back to this do something 1, once we've unwrapped, or I like to call it unwrap. So once we unwrap the recursive call, we sort of recurse down to the base case. The final solution would just be 1 plus 0. So basically, this like do something is only part of the final return method. So this is actually what we run a return in the end. And this do something, we're only like solving for a part of the final return like value. Yeah, so basically we have like this recursion workshop. Just a heads up though, this one is set up a little differently than like our usual workshops. So basically for this one, we've already given you a recursive method, and it's your job to basically identify like what's the base case, and explain like what each part of this implementation of this recursive method means. So like, what does this line mean? Why do we have this? Also like, what does this line mean? And like, why do we have it? And then finding like, what is this? Like, what do these lines mean? Like, for example, is it a recursive call? Is it a base case? And then what's sort of like the logic behind this method? So, and then you can either like answer it directly in the replit and like in the comments, or you can answer it in the submission form. And finally, we would really, really appreciate it if you gave feedback for this class and like the previous classes in general. It really helps us when students give feedback, just so we know like what can we tweak for like the next time we teach this, and what can we improve in the future.